Alright, so this video is going to cover 1.3, solve equations, but now the variables are going to be on both sides, okay? And this is going to cover worksheet 1.3, and I'm going to attempt, if I have storage in my flash drive here, I'm going to attempt to do these problems right here on your worksheet 1.3. Problem 13, 16, 17, and 22, okay? So let's get started so we don't waste time here. Okay, so first, let's go ahead and understand a few things before we even start doing an example. We're going to be solving equations when the variables are on both sides. So variables will be on both sides. Okay, the variables will be on both sides. And let me write a problem that you can understand what this means over here. For example, I can have 5x minus 3 equals 3x plus 12. So now I have variables on both sides. I'm not going to solve this one because I just made it up, but that's what it means. The variable is not on just one side, now it's on both sides of the equal sign, okay? On both sides of the equal sign, okay? Well, in order for me to do this, I have to pay attention to my previous skills, but also I need to remember one more thing. Our goal is to put all variables, on one side of the equal sign, okay? And in order to do that, my elementary school teacher used to say, let's sort the beans, let's sort things out here. So let's sort the variables on one side and the non-variables which are the numbers, just the numbers, on the other side, Okay, so we want to put variables, everything that has a variable, we want to put on one side, and everything that does not have variables, we need to put on the other side. So let's sort the beans here, sort things out. But in order to do that, students think that they just need to write a 3x on this side. That is not how it works. In order to do that, we must use, which is the opposite operation. We must use opposite operation so we can move things to move items across the equal sign. Okay? So I have to use the opposite operation to be able to move the items across the equal sign. I can't just rewrite it the way I want it. I have to use opposite operation. If this is a positive 3 and I want to move it to the left side of the equal, I better use opposite of positive 3x, which is negative 3x. So you need to use opposite operations. Let's do an example. I just wrote this here. It's not going to be divisible. Well, let's just do it. I just made this up, so it's not going to be a nice, clean solution, but let's do it. Let's put the variables on one side and the non-variables on the other side by using opposite operations. So I have a positive 3. I like to move the smaller from the largest. That's how I always do it. So I'm going to do the opposite of positive 3 is negative 3x. If I do it to the left, I better do it to the right. If I do it to the right, I better do it to the left. So I subtracted 3x. So 5x minus 3x, now we have 2x minus a 3 equals this positive 3 and this negative 3x here, they become 0, and we only end up with a 12. Okay? So nice. I put all the variables on one side. Let's put the non-variables in the other by using the opposite operation. So now the opposite of a negative 3 is a positive 3 and a positive 3. Okay, if we do it on one side, must do it to the other. And now I just have a 2x equals 12 plus 3, which is 15. Yeah, I didn't like it. I just made this up. I knew it wasn't divisible evenly. Now to get the variable by itself, like we learned in the previous video, we must use order of operations backwards, right? The PEMDAS backwards, and that's exactly what we were doing here. Subtract, and now divide by 2. Divided by 2, and x equals 15 over 2. It's not a nice, clean answer, but it is an answer, okay? So there you go. There's our answer. So remember, we started with variables on both sides. We just need to get them all put on one side, okay? That's our goal. So let's do some examples here from your homework. Let's start with, what did I say I was going to do? I said I'm going to start with number 13. So let's see number 13. 1.3. Let's see number 13. We also, the reason why I want to start with number 13 is because when you solve this type of equations, you will get 3 answers, okay? You either will get something that's called an identity, or you'll get something that's no solution, or you're going to get something that is a solution, okay? So there's only 3 possible answers, and I want to show you these 3 possible answers when you solve this kind of equations. Okay, that's why I picked number 13. Number 13 says 6 times quantity of 4z plus 2, and that will equal 3 times the 8z plus 4, quantity 8z plus 4, okay? All right, so let's see what we get here. I guarantee you once we're done solving this, we're either going to get something that is called an identity, no solution, or we will get a solution for the variable here. In this case is a z. Okay, so this is a z, and this is a number 2, okay? All right, so remember the 3 things we need to always check. First, distributive property. Do I need it? Yes, because I have a multiplier times a quantity. So 6 times 4, positive times positive, is 24z. And 6 times 2, positive times positive, is 12. Okay? And that's going to equal 3 times 8z, positive times positive. 3 times 8 is 24, the letter z, the variable. And 3 times 4, positive times 4, positive times positive, positive 12. Okay? So we use the distributive property. We use the distributive property successfully. Now I need to combine like terms. If I have more than one z here on this side, I would have combined them. If I had more than one z's or more than one number here, I would have combined like terms, but there's no need for that. Okay? I am in a situation where I have variables on both sides. So I need to move variables to one side. Okay, so let's move the variables to one side. And by doing that, I have to use opposite operation. But if you stop here for a second, if I subtract 24z from 24z over here, it's going to go away. It's going to be 0. If I subtract 12 from a positive 12, it's also going to give me 0. So subtract 24z, subtract 24z. That gives me 0. 24z minus 24z is 0. 24z minus 24z is 0. I end up with plus 12 equals plus 12. Okay, this is looking kind of interesting. If I subtract 12 from here, subtract 12 from here, we end up with 0 equals 0. And that is called the identity. The identity answer. Okay, we end up with 0. Now, if you look a little bit back, if we rewind this, you'll see that that was the identity right here. 24z plus 12 equals 24z plus 12. It's exactly the same thing. So I have the identity answer already, right here. The same thing on the left as the same thing on the right. If I subtract them, they'll cancel each other, become 0. We end up with zeros. So that's the identity answer. Okay? Now, let's do a problem where we don't get the identity answer. And that is why I chose number, what did I say? Number 16? Yeah, let's do number 16. Number 16, negative 5 times x plus 7, and that is going to equal a negative 5x plus 35. A negative 5x plus 35. Okay? So let's see what we get here. Let's work on this one slowly. We might get identity, we might get a solution, we might get no solution. We'll find out. All right. Looks like I see a multiplier times a parenthesis. We are going to use the distributive property. So negative 5 times an x, that's negative 5x. Negative 5 times a positive 7, negative times positive, is negative 35. And that equals negative 5x plus 35. Now, usually if you're careless, you will look at this and say they are exactly the same, therefore is an identity. They are not the same. I have a negative 5x, yes, that's nice, check. But this is a negative 35 and that's a positive 35. So these are not identical to each other. It's not an identity. So let's keep going. I'm supposed to move the variables to one side. So let's do the opposite of negative 5x and add 5x. If I add 5x here, I better add 5x to this side. Okay? So a negative 5x with a positive 5x on this side of the equal equals 0 plus 35, which is just 35. And over here, we have a negative 5x with a positive 5x, which is 0, and that equals a negative 35. 0 minus negative 30, minus the 35. So does negative 35 equals a 35? I don't think so. They don't equal each other. This is a no solution. Okay, no solution. Okay, it's a false statement. A false statement. Okay, and the false statement could be anything. You could get any sort of false statement, like 0 equals 7. That's a false statement. That's a no solution. You could get 2 equals 10. That is a false statement. That's a no solution. Okay, so the no solution may appear any kind of a false statement. That's a no solution. Okay, so now you know what an identity answer looks like when you solve it. Now you know what a no solution looks like. And from my previous example, you saw what a solution looks like, right? So whenever we're solving variables, we could get 3 kinds of answers: identity, no solution, or a solution. Okay, let's solve for the last one. Let's solve, do I have room here? Yep. Let's solve number 17. So number 17 is a little bit tricky because there are decimals, and students don't like fractions nor decimals. And this is 5.5 minus 3b equals 2b minus 6.25. All right? And I'm supposed to solve for this variable and check what kind of answer do I get here. I need to solve for b. What is b? Well, I don't need to use the distributive property because I don't have a number times a quantity. So I don't need, no distributive property here. Okay, I don't need the distributive property. Check. I don't have parentheses. Do I need to combine like terms? Do I have, let me cover this side. Do I have more than one b on this side that I need to combine anything? No. Neither side I need to combine like terms, so I'm okay. No need to combine like terms. So no combined terms needed. Check. So I'm going to go ahead and move things across very slowly. I always like to do the smaller, so start with the smaller variable instead of the bigger variable. The opposite of a positive 2b, it's negative 2b. If I'm going to do it here, I better do it here as well, across the equal sign. Okay? So a positive 2b and a negative 2b, it's 0. I'm going to end up with just the negative 6.25. On this side, we have the 5.5, negative 3b, and negative 2b is a negative 5 times the letter b. Okay? Now I'm almost done. I want to get this b all by itself. Our goal is to isolate the variable b. Okay? I want to isolate the variable b. I want to get this all by itself. So I'm going to subtract 5.5. If I subtract it from the left, I better subtract from here as well. 5.5. And I can add a 0 here. Okay? All right. 5.5 minus 5.5 is 0. I end up with just my negative 5 times my b. Okay? Let's add this together. 5 plus 0 is 5. 2 plus 5 is 7. And negative 6 with a negative 5 is negative 11. Okay? There we go. We're almost done. We just need to divide by, opposite of multiplying by a negative 5b times b is dividing by a negative 5. I want this to become a 1, and negative 5 divided by a negative 5, it is 1b. If I do it to the left, I better do it here, negative 5. Okay? And when I divide a negative 5, negative 11.75 divided by 5, let's see, let me use my calculator here really quick. And negative, let me see, 11.75 divided by 5 gives us 2.35. 2.35. Okay? And there you go. 5 does go inside of 11 twice. Okay, so there we go. 2.35. And that is our letter B value. Okay? We isolated, we solved it, and we got an actual answer. So this is a solution. Okay? So we got a solution. There's an example with getting a solution. There is an example with getting a no solution. And there's an example with getting an identity. So those are the 3 answers you get when you solve for variables on both sides. Okay? Always make sure to check if you need distributed property. If not, move the variables. That's always I do every single time. Okay? All right, so this should help you, plus the notes and examples I do in class, both of them together. This should help you do this homework for 1.3. I try to do a variety of decimals, fractions, problems here, and word problems to help you out. The rest should be very similar. If you need any help, come and see me. And good luck on this homework.